So if we look at y equals 3 to the x, it's just a reminder because it's been quite some time since we did exponential graphs. And I gave you y equals 1/3 x. Can I compare them right now? No. What do they have to have in order to compare them? Common base. We don't need you right now. You go away. We need common base. So, how can we're not going to change the first one because the first one becomes the second one, correct? So we have to change the second one's base to match the first. So some people always want to change the fraction one. If it was like this, if it was, I love this board. It's great. Okay, if it was like 1/3 x becomes y equals 3x, you would have to change the 3 to the power of x, right? You always have to change the second one to match the base of the first, because the second one's the one that's transforming. You agree? So how can I change 1/3 to be 3? I hear whispers, but I cannot hear what you're saying. Raise to the exponent, -1. So the 3 can come up to the -1, the x, which is just 3 to the -x. Now this one I would want to make be 1/3. Well, how can I make it be 1/3? I can raise 3 to the power of -1. Bless you. And I get 1/3 to -1. Either way, it's a reflection in the what? When it's with the x, it's a reflection in the, because it's making your x's negative, right? So if all that happened here is I would have a reflection in the y-axis. Now, what do we remember about exponential graphs? Exponential graphs have an asymptote. If there's no vertical translation, they have an asymptote on the x-axis. What's the equation of the x-axis? Y equals 0. And what kind of asymptote is this? Horizontal or vertical? Horizontal, because it's a horizontal line, right? So this is a horizontal asymptote. Now, if we had 3 to the x, if we just had y equals 3 to the x, what do we know about that? My b is greater than 1. If my b is greater than 1, what's happening to my graph? Remember exponential word problems? If your b is a 3, what's happening? So much swaying of hands, so many ways. If your b is a 3, what happens in an exponential? It means your r value is a 3. What's happening? It's tripling, it's steeper, yes. And the bigger the number gets, what happens? Yeah.
The closer it gets to the y.
Right. So if we look at 3 to the x, it's going to do something like that, let's say. That would be y equals 3 to the power of x. But if I did 10 to the power of x, it would grow steeper faster, right? Because it would be 10ing. Instead of like doubling and tripling, it would be 10ing. I don't know what that is, but I'm going to call it 10ing. So it would still run along here, but then it would run steeper. So the bigger your b value, the closer it is to the y-axis because the faster it's growing. We agree? If I do 1/3 x, you just told me if it's 1/3 x, it's a reflection in the y-axis of 3x, right? So I would reflect this over here, and then I'd reflect that down here. This would be y equals 1/3 x. And it's a reflection in the y-axis. Let's pretend it's perfect. It's not, but you can pretend. So what happens when my b value is between 0 and 1? What's happening? It's decreasing because it would be 30. Not doubling, not tripling, it would be 30, right? So if my b is between 0 and 1, it's actually decreasing because you have less than 100% of the original. And if greater than 1, it's increasing. Now, if it's just in the form of y equals a b to the x, the a value is your y-intercept. But that's if there's no transformations on it. So like if it was y equals 1,000 to the x, this would be your y-intercept, which makes sense because it's your initial value in a word problem, right? And your y-intercept is when time or x is 0. So it only works when you have y equals ab to the x, correct? Now if you sketch a exponential function really fast before you go to answer anything, it will help you. So if I'm given any type of equation, let's say I'm given y equals negative 2x plus 1 minus 4. Let's pretend that that's the equation I'm given. And what would it have to have been originally? Well, it could be transformed, but I'm just going to make it be 2 to the x. And I can only compare them because they have the same base. We agree? So I know, because it's a base 2, what's happening to the graph? It's increasing, right? I know it's increasing. So if I drew a basic exponential function, it would be like the base function of this one. It would be something like this, and then it would be doubling. So it would be like that, let's say. It's just totally random. I'm just drawing a very quick sketch. We agree? That would be of the 2 to the x graph. What's the only thing that can make that asymptote move if it's horizontal? Your vertical translation. So remember, from exponential functions, your asymptote is your vertical translation. So we know from exponential graphs that the horizontal asymptote is y equals your vertical translation. The only other thing that could happen is I could ask you, well, I can ask you for domain. Let's say I ask you for the domain. What's the domain of every exponential? Yeah. X such that x and l are the reals in set notation, or negative infinity to positive infinity in interval notation. What about range, though? Pardon? You guys whispering. I like just...
Y is greater than 0.
Why?
Because there's a asymptote. Y equals 0, so it can't equal 0.
Right. So it would have to be above. What's the only thing that can make it be below? The asymptote could move with the vertical translation, but what's the only thing that can make my range be less than? A reflection in the what? In the x-axis, because it would have to be up here and it would have to come down to here. Where do I find a reflection in the x-axis? Still whispering. With the a value. So if this a value here is negative, that's a reflection in the x, correct? And this here gets me my vertical translation, which also gets me my horizontal asymptote. So if I want range, I'm literally looking at this back number for what the number is, and then this, if it's negative, it's less than. If this is positive, it's greater. That's it. It's either going to be above if this is positive, or if this is negative, it's going to drop it below the asymptote. So this particular one, the range would be, I'm intentionally doing these in Christmas colors, y such that y is less than negative 4 yer. Or negative infinity to negative 4, round bracket, because it's not equal to. What's my asymptote on this one? Y equals? What is it? I'm literally still there. What's your vertical asymptote, or your horizontal asymptote? Negative 4. Yeah, I couldn't hear anything you guys are saying. I'm going to start teaching in whispers. Because I feel like everyone answers in whispers. Either that or I'm getting my hearing checked. All in whispers. Can you guys hear them? Okay, Jumari is going to be my translator. Because he can hear you, and I can't. And he's the only one who nodded to that hearing. So, Jumari, you are now the translator for the class. Welcome. All right. So, we have this equation. Y equals 4 to the x, and it's becoming y equals 4x minus 3 plus 6. I want mapping. I want Transformations. I want the asymptote. Domain. Range. X-intercept. Y-intercept. So mapping, we would just have xy becomes x plus 3, y plus 6. Because you're going 3 right and you're moving 6 up, it's what you do, what you say. Then there are only transformations. You do not state, I don't know where I was going with that, state the 4, because the 4 just has to be the same in both cases. It's the base, it's not any of your transformations. So here I have a vertical translation. Six units up. You want to be particular? And a horizontal translation. Three units right. Okay, what's my asymptote at? Horizontal, vertical, what is it? It's always a horizontal if it's an exponential. And it's at y equals 6. What's my domain? X such that x and m in the reals, or negative infinity to positive infinity. My range? Y such that y is, it's greater because there's a plus here, right? If there's a minus there, it'd be less. That's the only thing that changes it, because it would cause it to reflect in the x-axis. So it's greater than my asymptote, which is 6 y-er. X-intercept, you set y equal to 0. So we're going to go through how to solve this algebraically, because we can now, because of lots. So we have 0 equals, is y equals 0? When you have x-intercept, 0 equals 4 to the x plus 3 plus 6. I can't make common base, I'm going to have to convert to a log. The only way I can convert to a log is if I have 3 pieces of information, right? Right now I can't convert it. So I need to subtract 6. And I get negatives, yep.
Is it x plus 3 or x minus 3?
That's a minus. Good catch. That would have sucked. Minus 6 equals 4, x minus 3. And then we do log. Base of my exponent becomes the base of my log. This goes beside it. And then it equals x minus 3. What is going on here? This is a problem. It would fight you, wouldn't it? Why would it fight you? Because it's negative, it's not possible. So I can stop right here. Because there are no x-intercepts. Now, how the heck are there no x-intercepts? Let's look at our range. Our range is greater than 6. The whole graph is above 6. Is there anything on my x-axis? No. When you get a negative beside a log or a negative in the base, it's done. Okay, y-intercept's much easier. Y equals 4, 0 minus 3 plus 6. Y equals 4 to the negative 3 plus 6, which is some sort of fraction. What do we get? Jamari, translating. Ah, now you're paying attention to translation. Because 4 to the negative 3 is a number. It's 1 over 64 plus 6, which is not 6.
Why wouldn't it just be 1? Because didn't earlier you say that the a values owns the y-intercept?
Only if it's in the form y equals a, b to the x, no transformations. There was a caveat on that bad boy. 6 point what? Well, math ends their entrance, so that baby's not stopping, is it?
385 over 64.
Hold on, that was better. Yours is
385
over 64. The volume is slowly increasing. I like this. I wish I had like a little button, just like on a computer, you just tap it a whole bunch of times. I don't even know that movie.
You've never seen the movie?
No.
This movie of all time.
Christmas, holidays. I now have a movie to watch. I do love Adam Sandler. Okay, one question. Okay, guys, Lucas has a question which I'm going to clarify because people messed it up. So if we have y, he said, what did I say about the a value? If it is in the form y equals a b to the x, no transformations. So no vertical translation, no horizontal translation, no reflections, right? Your a is your y-intercept. Because this would be in the format of any of those exponential word problems, right? Where it would be the initial value, and your initial value is when time is 0, so it's your y-intercept. But if I put an x plus 2 on there, done. Okay. What if I give you this? Y equals to base 3 x plus 6 minus 4. Are you ready? This should be f of x. I want the what? Wow, that's a large F. It's bulking up for Christmas. Okay, I want the inverse. What's your first step of inverses? Make x be y and y be x. What's the inverse of an exponential? We talked about this already. A log. And what's the inverse of a log? An exponential. So what are you going to have to do? You're going to have to swap the x's and y's and convert it to a log. And if I give you a log, you're going to have to swap the x's and y's and convert it to an exponential. That's what you're going to have to do every single time. So we'll do this one together. We're going to get, instead of f, we get x equals 2 bracket 3 to the y plus 6 minus 4. Now I need to have 3 pieces in order to convert it to a log. I need a base, an exponent, and then I need it equal to something, correct? Currently, I have it equal to something with something in front and something in the back. So I have to move some stuff first before I can convert. Because I need a base, an exponent, and then something over here. So this negative 4 and this 2 are problems, right? How do I move them? Add the 4 first, because you have to reverse bad math when solving. So we get x plus 4 equals 2 bracket 3 to the y plus 6. And then I still have to divide by 2. Now I have 1, 2, 3 things, and I can convert it to a log. So I'm going to get the base of my exponent becomes the base of my log. So I'm going to get log base 3. What's with it doesn't stay with it. So it equals x plus 4 over 2. And then, or what goes beside it is x plus 4 over 2. And it equals the exponent always, y plus 6. Now x plus 4 over 2 isn't a problem. But if I ask you for transformations, it actually makes it harder if you do it like that. So instead of writing the 2 in the bottom, what you can do is write the whole x plus 4 to the half. So you can go y equals log base 3, 1/2 x plus 4. Because remember, if you want to state transformations, you need to have the fraction outside anyways. Minus 6. Now we did talk about log functions before this. We said the base of the logs have to be the same in order to compare them, and the base of the log doesn't get written in transformations. So that 3 would be nowhere in my transformations or my mapping. But we talked about basic log functions. Instead of having a horizontal asymptote, they're going to have a vertical asymptote, which makes sense. When's the only time I actually have to find the inverse function? When it asks for inverse function, do I actually have to find it if I want the domain, the range, the x-intercepts, the y-intercepts, any of that stuff? No, I can go to my exponential and I can state the x-intercept, the y-intercept, the domain, the range, and then just the x-intercept would become the y-intercept would become the x-intercept, the domain would become the range, and the range would become the domain. So the only time I actually have to find the inverse equation is if it says determine the inverse equation, right? Now, basic logs have the y-axis as their asymptote. So they have a vertical asymptote. What's the y-axis equation? What's the y-axis equation? X equals, I'm going to pretend all that whispering is zeros. And then your log is either increasing, so it's running down here and then up, or it's decreasing. Now you have to watch yourselves, because if you type in, just type this in. We're going to look at that one in a second, but just type in y equals log base 3 of x. Just type that into your calculator. So if I go math log base 3 of x, or if you have the old calculators, you'd go log x divided by log 3. Either way, we have this. And I get the worst drawing graphs known to man. The range of an exponential, or sorry, the domain of an exponential is XER. Everyone says that, everyone sees it, it's all good. It actually kind of shows it the whole way on the graphing calculator. But for this one, it cuts it off, and I don't know why it actually cuts it off. I think because it gets so close to the y-axis, it literally can't draw it because of the pixels. But that graph keeps going. The domain of an exponential is XER. The range of a log is YER. But you guys will tell me it's greater than 2 for this, -2 or something for this one. It's not. This thing actually keeps going all the way to negative infinity. It just gets extremely close. Remember, logs are just exponentials inverted, like the inverse of them, right? So if I threw myself the line y equals x on here, I would actually get, let's pretend that's perfect, it's not. I would get the reflection on the line y equals x. One would be exponential, one would be a log. We agree? Well, this one, it draws the whole way along, but your calculator stops here, and I think it's due to pixels. Like, it literally just can't draw anymore. If you go to your table of values, it'll show it. Sometimes it'll error because it's so close to 0, it doesn't know what to do with itself either. But you're smarter than your calculators. So when it cuts off a log, don't cut off a log. Okay? When it's just a basic log function, it keeps going on for life. A log range is YER. So the range of this is y such that y is now in the reals. From negative infinity to positive infinity. Okay, my asymptote on a log is vertical asymptote. What's the only thing that can move that bad boy? Horizontal translation. If on a test, if you do this for exponential, the only thing that can move it is this. For log, it's this. The only thing that can move it is this. So if you have to use your arm to move it yourself, do it, because that helps me out. Only thing that can move it is a horizontal translation. So what is the actual asymptote of this equation here? Oh my goodness, vertical asymptote. What's the vertical asymptote of this one? X equals -4. Because all that matters is the horizontal translation. The stretch doesn't make it wider or narrower or anything, right? It changes the whole rest of the graph, but it doesn't change the asymptote. The only thing that can move is your horizontal translation. And then my domain is going to be x such that x is greater than -4, not equal to. Why is it greater and not less? Because for logs, we look at just here. If this is positive, it's greater than. If this is negative, then there's a reflection in the y-axis, which causes it to be on this side. Right? Reflection in the y-axis, it causes it to reflect in the y-axis, and then it would be over here. This one just happens to not reflect in the y-axis, so it's greater. Now my x-intercepts of that one, I'm going to go 0, because x-intercepts y equals 0 every single time. Doesn't matter what equation I give you. y equals log base 3 of 1/2 x plus 4 minus 6. So what am I going to have to do first? I'm going to move over the 6 because until I have log base equal to something, I can't convert. We agree? So I'm going to add the 6 over. And so I get 6 equals log base 3. And if I need what's beside the log or in the base of the log, I'm going to have to convert to exponential. So I'm going to get base 3, exponent is 6, equals 1/2 x plus 4. 3 to the 6 is a lovely number, of which I don't know what it is. 729? I'm totally guessing. It is. That was a random guess. 729, 1/2 x plus 4. What am I going to have to do next to get x by itself? Multiply by 2 is what I hope you said. I don't know. 729 times 2 is 1,458 equals x plus 4. And then what am I going to have to do? Subtract 4. So it's at 1,454 and 0. It's a large x-intercept. Okay, what about my y-intercept? Yo.
I'm so confused as to why the variable asymptote is.
Because the only thing that can move an x equals 0 is the horizontal asymptote. Is the horizontal translation, I mean.
Oh, okay.
So the only thing that is the horizontal translation is 4 to the left. So it takes that asymptote and shoves it 4 to the left. So now instead of it being at x equals 0, it's at x equals -4. Exponentials are y equals 0, so the only thing that moves it is the vertical translation.
So because it's the inverse, we take the from the horizontal asymptote, or we can go to the
Okay. And then our y-intercept is much easier. We're going to get y equals log base 3 of 1/2, 0 plus 4 minus 6. So we get log 2 divided by log 3 minus 6. Now some people will say, well, I actually can't have a y-intercept. You can't have a y-intercept on a basic log function where the asymptote is on the y-axis, correct? But is this asymptote on the y-axis now? No, it's on -4 and the graph is greater than it. So you will have a y-intercept. Okay, I want you to flip to your notes to this page. And then Tuesday and Wednesday we're reviewing. Thursday is your test. Friday we're doing binomial theorem. It's helpful stuff there. It's in the middle of your notes. It's right after word problems, I believe, and some graphs and stuff. Should be right there. There should be right away. What's that? After that? Yeah, it's after log laws. Yeah. It's after log laws. Okay. I don't need you to sketch it. I'm not concerned about that, but I do want, with y equals 2 log 2x minus 1, I want the equation of the asymptote, I want the domain and range, and I want the x and y-intercepts if they exist. Before I go to state my any transformations, what should I do with that log? What? You can put a base 10, sure, but what else? Take out the 2. Just from transformations unit. You can't have anything in front of your x if you're going to state the horizontal translation, right? You have to remember to always take that b value out, and you have to remember to always have a 1 in front of your x. So I want you don't have to graph it, I just want the equation of the asymptote, domain and range, x and y intercepts if they exist. Logs have vertical or horizontal asymptotes? Vertical. So a vertical asymptote, normally at x equals 0. This one's going to actually be at x equals 1, because it's the horizontal translation. My domain of a log is going to be x such that x is greater than 1, because this is a plus 2, it's not going to be less. So it's greater than 1, xer. What's my range of a log? Yer. If I want an x-intercept, I have to put y equals 0. So I'm going to go 0 equals 2 log base 10. Because if you want to convert, you need a base. 2x minus 2, I'm just going to use the original, minus 1. So I'm going to add 1 equals 2 log base 10, 2x minus 2. And I'm going to divide by 2. 1/2 equals log base 10 of 2x minus 2. So I get base 10 of a half, because you convert to exponential after this, equals 2x minus 2. So I'm going to get 10 to the half plus 2 equals 2x, and then I have to divide by 2. So x equals the square root of 10 plus 2 divided by 2. 10 to the half is the square root. Yep. So you can get 2.58. Whenever it's an x-intercept or a y-intercept, it is a coordinate. It's not just 2.58. It's 2.58, comma, 0. Then my y-intercept is usually easier, because it's y-intercept x equals 0. So I'm going to get y equals 2 log base 10 of 2 times 0 minus 2 minus 1, and I can literally just type it in. So 2 log negative 2 minus 1. Ah, it screams at me. Why does it scream at me? Some people were actually starting loud and then just petered off when someone else answered. So if you put a negative 2 beside a log, what happens? We got issues. It's not real, right? So this would be no y-intercept. Does it make sense to not have a y-intercept? Yeah. The domain is greater than 1. So the whole graph is greater than 1. So there won't be a y-intercept. There shouldn't be a y-intercept. If you're finding one, you got problems. Yeah.
For the x-intercept, would you rather us leave it an exact value or make it a decimal?
It depends on what they ask for. Yeah. Whichever one's better is the one they ask for. All right. So here it says, determine the transformations associated with each of the following y from the equation y equals base 3 of x. So they all have to be base 3, correct? So you are going to state the transformations and mapping. I want transformations and mapping for 1, B, and C. We're going to call this an A. That's just dumb. A, B, and C. And then determine the domain and range of A, B, and C. And then state the equation of the previously transformed. No, I want to state the equations of the asymptote. Don't know what this is. Ignore that. A, B, C. C is the equation of an asymptote. Transformations mapping for here, domain and range for here, and then the equation of the asymptote in C. The first one, what do I have to do before I can do anything? Take out the 2. So I'm going to get 2 log base 3, take out a 2, x minus 1/2. So I get any stretches. I have a vertical stretch, I'm using short form because it's my notes, but I'm not allowed to on the test, by a factor of 2 about the x-axis. Let's go super lazy on the next one. Horizontal stretch by a factor of, if you do this, you're getting no marks, just so you know, on any test. Test diploma, HSBAFO, no, 0. 1/2 about the y-axis. And then a horizontal translation, which if you go HT, you aren't going to get any marks either. 1/2 right. So I can only use short form because it's my notes. The 3 doesn't appear anywhere because it's the comparable base. So xy becomes 1/2 x plus 1/2. And then y is 2y. The next one I'm going to have to divide the 3 over. Watch when you divide the 3 over, it has to go to all the terms. So when you divide the 3 over, it goes to this, and to this. And then the 3 here, I will tell you to write in front as a 1/3. So we get 1/3 log base 3 of x plus 2. And so I get a vertical stretch by a factor of 1/3 about the x-axis. Remember, no short form on tests or on diplomas. And no horizontal stretch, and the only thing I also have is vertical translation, which I have to write full out if it's on a test. Vertical translation 2 units up. And then I get xy becomes x, because there's nothing with the x, 1/3 y plus 2. For C, I have to move the 3 over and take the 3rd out. When I take out a fraction, what actually ends up happening to the number? You end up multiplying by the reciprocal, right? So if it's a 3rd, you multiply by 3, so the number actually gets bigger. So we're going to get y equals 1/2 log base 3. When you take a 3rd out, you're all basically multiplying by 3. You get x minus 3, minus 3, and moving this over. So I have a vertical stretch by a factor of 1/2 about the x-axis. A horizontal stretch by a factor of 3 about the y-axis. And then a vertical translation 3 units down. And a horizontal translation 3 units right. And mapping, that would be xy becomes 3x plus 3, comma 1/2 y minus 3. Your domain is the thing that changes for all of these, right? The range is YER for all 3. Your domain is going to be x such that, is there a negative with the 2? No. So x is greater than 1/2 xER in set notation, or 1/2 to infinity, round bracket. My range is YER, it's a log. Unless it's a word problem, it's YER. When it's a single log. The domain for this one is going to be x such that x is, it's nothing with the x. So it doesn't change, it's just x is greater than 0. If there's nothing with your x, it just stays the basic log, which is 0 to infinity. And then the range is y such that y is greater ER. Don't know where I was going with that. Negative infinity, positive infinity. And this one, my domain is going to be x such that my 3rd is positive, so it's greater than. 3 is the right. XER. All of these are greater because there was no reflection in the y-axis. So it didn't, if there was a reflection in the y, it would be, instead of being here, it would be here. Let's make it less. And then the range is y such that y is now greater than. And then here you have a vertical asymptote. Am I allowed to short it to BA on any test? No. Vertical asymptote at x equals 1/2. That's when you have a vertical asymptote at x equals 0, because there's no horizontal translation. And this when you have a vertical asymptote at x equals 3. Your homework for this is the last lesson for logs and exponentials, so the next 2 days we're reviewing, so bring your A game. Doing some serious review. You can try the diploma practice as well. What would the x-intercept, I want to do this one first. What would the x-intercept be for this one? Y would be 0. Can I convert to an exponential right now? 1, 2, 3 piece of information. So the base of my log becomes the base of my exponential. Goes to the power of 0 equals x minus d. What's anything to the exponent 0? So I have 1 equals x plus d. So x, or minus d. Add our d over. X equals 1 plus d. Which is actually c. Okay. Number 5. It's actually technically page 390, but who cares?